Hi everybody, thank you for joining me today. We're going to go over the drawings for the dim bulb Variac panel, electrical and mechanical. Hope you enjoy the show. Thank you for tuning in. We're going to get right into it. Thank you. Okay, we're recording. All right, let's go. Hey, we're going to get into the schematic today on the Variac dim bulb panel. I thought I had all of the components handy, and it turns out that I didn't order the panel meters, which was a big surprise to me. I could have swore that I had purchased them a while back, but I did not. So there will be a minor change to the schematic. Nothing in wiring, just the labeling of the two components. And we're talking about this schematic here. This is our dim bulb panel and Variac schematic for the whole panel itself. We have our input plug here on the left side, which we will come through a fuse. That input plug itself is going to be this guy here on the panel. I elected to go this route so that there can be no question at all if there is power to the panel or not. Let's say if the LED was to burn out or whatever. If it's not plugged in, there's no power. Ultimate safety, 100% disconnect. So that's why I went this route. We go to F1, our fuse. That'll be a 5 amp slow blow, which then goes directly into our yellow display on the panel. That panel lamp will just indicate that there's power on the panel. There is live AC available on this panel. It may not be at the outputs yet, but it is available on the panel, which will also be, like I said, indicated by the switch. We have S1. S1 will then turn power on to the panel itself. Then our power flows through another switch, which you see is a 4-pole double position switch. And this will allow us to select between Variac and dim bulb or straight power all the way through. They are two separate lines and they are isolated from each other through that switch. This switch is also a break before make. We don't want to energize two systems at once, so we'll just do that to be on the safe side. Then we have the next switch here. This switch, S3, is going to allow us to select the taps that are on the Variac itself. If I select this tap up here in this position that shows in the normally closed, which it won't be in the normally closed, it'll be in the normally open position. But that'll go to the 140 volt tap. The other line coming down goes around here to the top end of the Variac itself. And if this was dialed all the way up, the highest voltage you could get is 120 volts or whatever your line voltage is at your house. Could be 110, could be 115, could be 120. So whatever it rolls out to be. Then from there, like I said, depending on which way we're routing, well, either way of the routing, power will be fed back through this violet line here, which will then go up and indicate on our panel meter the current that is flowing in that line and also the voltage. What I allude to that I forgot to buy these panel meters, so I elected to go from a 250 volt to 150 volt, which gives us more in line if we go to 140 volts on this particular tap. And then I also dropped this from 5 amps to 3 amps. I also purchased a 10 amp panel meter. So we'll see. I don't know. I can always switch it out as I need, but we'll see. I'm going to go with the 3 amp up front and go from there. Then, like I say, power's going to route back through this switch here. And if it's in this position, which is in line with this position, we will end up with power coming out this plug here, okay? Because we are not routing power down to our Variac. If we toggle that switch, which is this big guy right here, so this is our S1 switch. This is our S2 switch. And this is our S3 switch. These are all panel mount. I will be fitting parts onto the panel here, but since I don't have the panel meters yet, I will only build up all the components on the unit except for the 2 panel meters, and then once those arrive, then we'll do all the wiring with the installation of those 2 panel meters. Now, back to our schematic. If we elect to go to the Variac position, our power coming off of the tap will come back around, up, down, around, and then down the purple path. So that way we're using the both meters in both positions, the way that it's wired. And then of course it comes back on this line here, and if it goes out this direction, when we have it switched into the Variac position, power will be routed up this way through our dim bulb, which our dim bulb will be screwed into this socket right here. And that will go out straight out to the output plugs. Here's the output plugs that we are using for this particular panel. So this is pretty exciting that we'll have these. And then of course our panel lights, we have these 2 right here. We have obviously the red. These will indicate that power is live at the output plug, this output plug here, either one, depending on which one it is, that power is live at that plug. And this is our indicator that power is on the panel. This is just a warning indicator for us that, hey, you are plugged in and power is available. All right. Of course, we have all of our hardware and our Variac, which you remember from the modeling of the 3D modeling that I did about 2 years ago that I had finished up. And then we have our fuse plugs itself. So those will get mounted also in 3 different locations. And I bought enough fuses so that I can select the protection that I want during a given project. If I know that a project's not going to pull more than 1.5 amps, I may elect to go to 1.5 amps on the slow blow fuse that's at that particular plug. And I may elect not to. I don't know. It's just, it's a thought that I have, and we shall go from there and see how it goes. But schematic, as you see, is very simple. You'll also notice that the indicator bulb that I have at the dim bulb path comes straight off the tap here because I don't want it to vary with the intensity of the Variac if it happens to be dialed down to 20 volts or 75 volts or whatever it may be. So I wanted that to be full illumination, no matter what, if that path is selected and power is available at that location. Our dim bulb itself, which is a DB1, and that will just turn on instantaneously, hopefully, and right back off as we power up a project. If it stays on, we've got a problem that we need to take a look at. Okay, here we have our mechanical drawing for our dim bulb Variac panel. And here we just have our generic notes that we have for the manufacturer and what's on the drawing itself. We have our dimensions for holes and placements and blah blah blah. And back of the panel itself, this is all the X and Y locations and the type of holes, and then if there's any special feature on a detail, what it is. This is all laser cut, so the manufacturer shouldn't have any issues with achieving any of the radii that are called out on the panel itself. One thing that I did find afterwards, that I didn't compensate enough for powder coating, and specifically on the switch cutouts on here for the main switch, the dim bulb switch, and the tap select for the Variac itself. The key channel, once I got the powder coating off, was a good fit. Nice and tight. There'll be no play, no movement, no anything. Hole diameter is perfect, right on. So fit's going to be wonderful with these when we get into the build here in just a minute. And then, of course, here is our page for the digital print. And the call outs for different font sizes at different locations, and of course the logo location that is on the panel itself. Very, very self-explanatory for the manufacturer on the panel, and you see our finished outcome based off of the drawing itself. It was a really good job. Thank you, Protocase, for doing such an excellent job on my panel for me. Thank you. Thanks for tuning in to the Open Dave show on Open Dave's Designs, and I hope you enjoyed today's episode of the Variac dim bulb panel. Stay tuned for the build. It's coming up next. Thank you. Bye.